So here's an interesting problem. I just called it expanding tables, but go ahead and make sure you have access to that document, and you probably want it to be printed out so you can draw on it. And I've drawn it out here for us so that you can look at that larger. A lot of what this is going to involve is you thinking about things on your own by yourself, and how you see the patterns growing, and how you would decide to count it up. So it's important that as you're writing this down, you have your own unique work that is going on your paper while you're writing this, to show that you really were trying to think about how you personally see this. So let's go ahead and actually start in on this. So you can see the instructions here. We have a banquet that's being put together by Bam and Cam, and they have hexagonal cafeteria tables. Now, of course, if we had just one of these, we can seat 6 people, let's say, on each side. But let's say that they're going to be like lining a bunch of them up, like we showed here. So the first thinking exercise I want you to do here is, in the first row of the 3 tables that I put here, I want you to not just answer the question there, how many people can be seated, but also I want you to think, exactly how did you count this up? Can you find an easy way to count? And, aside from just like 1, 2, 3, 4, all the way around, can you try to find an easy way to count for yourself how many total people there are seated around the table? Okay, and that's gonna of course give us a total answer. But then down below, try to think of other ways. Maybe you don't need to fill out every single one, but try to brainstorm and think of other ways that maybe wasn't your first way of thinking about how you could count up those total number of people, or how you see it growing. You might even try adding on more tables and see if you can find a pattern of some sort. Okay, so go ahead and pause, and I want you to answer the first question now. How many people? And try to note on your paper, how did you count that in an easy way? Okay. So hopefully you have that done already, and maybe you're doing like what I'm thinking of doing. I'm thinking about maybe using some colors, right? So if I use some different colors to kind of show it. Now let's just get this out of the way, what the actual answer is, because that's not really the most important part here. Let's do this. Maybe this is how you saw it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we can actually answer this right now. Okay, there are 14 total people that can sit at 3 tables. Okay? Now, if I was going to use colors like I was talking about, I don't know, maybe this is a way you could do it. I could just think like, okay, these are all kind of coming in pairs, I guess, and there's like 2 ends there, possibly. Maybe you counted it that way. You might have done something a little different. Maybe you kind of, some students, when I ask them this, they kind of think of it as like these 2 that have 5 and 5, and then this middle one just has 4. So maybe you thought of it as like 5 plus 5 plus 4, right? And in fact, I'll even draw these in here. So 5, 4, and 5, like that. Or maybe you saw it like the other way. I'm mixing up my markers here, so let me just leave all the caps off. Maybe you saw like the 4, 4, 4, and then 1, 1. Maybe you saw it like that. Or let's see if I can think of another way. It's kind of hard to think of different ways, right? Or maybe you might have seen it in a sort of another way. You might have seen like this. Maybe, I think I've had students say it like this before, where you kind of have the in-betweens here, like 1, 2, 3, 4, 5, 6, 7, 8. So there's like 4 and 4 in between, but then you've got your 3's on the end. And either way, this is a beautiful way to show that even though 14's our total, we could break it up like 1, 4, 4, 4, 1, could break it up as like 5, 4, 5. We could break it up as 3, 4, 4, 3. And in any of those instances, we can kind of really see more deeply like the way that this is put together. And furthermore, it probably becomes clear to you that we're losing two spots, I guess, you know? Every time I put a table on there, I did have a space over there, but then I lost that space, and then the space that would be on the new table is lost. So I've kind of lost two spaces right here. Except there is one like on the end over there, I guess. So maybe we could also think of the space that was lost here in the middle table when I added it on was replaced with this one. So maybe you could almost think of it as we actually only lost one place. Okay. So all of those different ways are really cool ways of thinking about what's going on. Now let's explore this problem a little bit deeper and move on to the actual questions that were asked on the next page. Okay, so let's take a look and think together here. Before we thought about how we might count up those total into 3, but now let's think about what's going on as it grows. And this is very algebraic thinking like we talked about. So here's one table here, and we're going to think about, okay, every time I add tables, what's happening? And we sort of started talking about that last time. Okay, so to answer the first question from the question thing, how many could seat at 4 tables? I think it's going to be helpful. We could certainly just put 4 tables together and count it up, right? But again, our goal here is try to find a simpler, elegant, nicer way to count them up. So as we put another table here, what's going on with the total number of seats, right? So here's one table, we can seat 6, but one of those 6 has gone out, right? So you can think about, okay, well, how many total are there here? And then you can do the same thing with another table. And we already know the answer to that, right? There's 14 of them there. And what's happening is I add yet another table to that, right? We had 14, but we took away, it seems like we took away 1 and then we added more maybe? That's a way to think about it. There's lots of ways to think about it. Kind of a lot of it maybe goes along with how you counted it, right? So let's go ahead and just find some totals here. I want you to really think about easy ways and try to answer this yourself now first, okay? So now that we've talked about this a little bit more, I actually want you to go through all 4 of the questions here and try to do it yourself. And you can pause right now and do that, and then we'll come back and look at it together. Okay, so let's answer with 4 tables here. There's lots of ways of thinking about it. You can think of this one, you have your 2 ends, and then it seems like there's like 2 on top for each new table, and then 2 on the bottom, so like 4 more every time. And you could actually almost think of this first table like that. We have 1 and 1, and then 4, right? Now actually, we've taken this one away, and this one has 6, but this one kind of, when it matches up, also takes away. So these are out. So I almost think of it as like we have 1 and 1 again, and then 4 and 4. Does that make sense? So it seems like we have 1 and 1, and then for every time we add a new table, that one's replaced by that one. So we still have the 1 and 1, but all we've done is added 4 more. So hopefully you came across that realization when you were working on this. And then seems like, again, we still have the ends 1s, and this new table has simply just added 4 more. Okay? And there's lots of ways you can record this. Another way I would really recommend is if you think about the number of tables as like an input and the total people as like the output. So if I have 1 table, there's 6. If I had 2 tables, well, if we're going by what we said, or if we counted them up, right, we'd have 2, 4, 6, 8, 10, right? And then if you added this one on there, you could see we have 14 with 3 tables, which we found before. And then with 4 tables, it seems like we have 18. So, judging by these patterns, I'll bet you we can answer for the rest of them, for 4 and 5 and 6. And if you don't have any, if you didn't write a table, that's great. Make sure that you have your work there, okay, to check. But that if this is a new way for you, you can write this down too. And then 5 has 22, and then 6 has 26, etc., etc. So it seems like we got that down. So we've answered number 1 here, right? So for numbers 2, 3, and 4, I'm going to go ahead and give you the answers for number 2 and 3 right away. Okay, for number 2, for 10 tables, 42 people could be seated. For number 3, we could not seat 80 people exactly. Like, there would not be a perfect amount of seats for everybody for 80 people, right? Like, if we extended this table, we're never going to get an exact output of 80 for a certain number of tables. That doesn't mean we can't seat 80 people. We just, we have a few extra. We just need to add another table on the end, right? So if you were to figure that out, you get 19 point something to fit 80 people. So we need 20 total tables, and not all seats would be filled then. Now, number 4 is really a big thing here because it's a big focus of our next topic that we're going to be looking through here, is that even though we might come up with, because you may come up with a formula that's correct, but there might be different versions of the formula that are all equivalent to each other. And we've talked in the past about equations that are identities, and we'll get into that a little bit more, but we're going to look at different ways of putting together a formula. Now, again, since I said there are lots of ways, we could look at the table, we could even look at how we saw it growing here. I'm going to maybe start out by building off of this guy right here, because it seems like directly, if you want to think about it here, notice that all these are having 3 tables, but if we break down the numbers, do you see how, and this is what I talked about when we built the table, this table as well, it's kind of confusing, table, is we talked about how there's just the 2 end pieces are always staying constant, and then every time you add a table, it's just adding 4. So I almost think of this as like 2 is just staying there, plus some 4s. You know what I mean? And that's one way I've kind of been thinking about this. So in the case here for this, I'm thinking of, well, we have the 2 on the ends, but then there are 10 tables, so 2 plus 4 times 10. That's kind of how I thought about it here. And then maybe to answer number 3, I could almost say, okay, well, 2 plus 4 times, well, we usually use variables, but we could also just use a little symbol for a table. We want to know if that equals 80, right? Or when that equals 80. And if we solve this by backtracking, we can subtract 2, right? Because this is saying some number, and I'll change it to an x there, some number times 4, and then plus 2 equals 80. So to reverse that, to backtrack it, we're going to subtract 2 and then divide by 4. So what I get here is 4x equals 78, and then after that, I don't have to move this, x equals, well, 78 divided by 4. And 4x equals 78, and so we just need to divide by 4 on both sides, and if we divide by 4, we get 19.5. And clearly, that's not a whole number, of course, so there's not an exact number of tables that will perfectly fit 80 people. But if we just round that up, of course, we can use 20 tables, right? So again, I use this idea here, and it seems like there's a pattern forming here. Now, number 4 really says n tables, so I suppose now that I look at it, I could have used or should have used n here so that I keep consistent with what n stands for. And, well, maybe you can already think of a formula here. And here's the cool thing. Since we're familiar with using function notation, and this is a function, I'll use p for people, and then n is tables like we said. And so p of n, what would be a formula for this? And we'll talk about different versions of the formula, but a formula that seems to be sticking out to us right now here is actually built on this equation we already had set up. We're really wondering, this guy, when he's going to give an output of 80, right? So it's almost like this is what 80 is, and check and see if you got 2 plus 4n. You might have got something different that's still correct, and if you simplify it, it's still equivalent to 2 plus 4n. So there's all the answers. And again, there's many correct ways you could have actually figured this out. You did not have to do it the way that I showed, and so many different ways of good thinking. Now, I based everything that I just did on this first initial pattern here. But what if we thought of this in a different way, like with the second pattern? I'm going to go ahead and have to erase a little bit of the board here and erase number 1, which you should have written already. And let's take a look here. This one is based on saying 2 plus some 4s, right? Like I said. And then this one right here is, it's almost like we have 2 5s there. And if you imagine we could add, if we added, squeeze another table in there, we still have the 2 5s on the end. You can actually think of that as 10 plus some 4s actually. Now really what's happened is, if you want to think about it, we've almost, do you see how we've kind of lumped these orange 4s, that 4 and this 4 over there and there? We've kind of borrowed 2 4s from over here and put them over there, right? Because 2, if you add 2 4s to it, makes 10. And this one right here is actually almost as if we borrowed like 1 4 from it, because this actually is the 3's on the end, so it's 6 plus some 4s, if that makes sense. Now this one is just, if we take 2 and we kind of borrow 1 4, 2 plus 4 is 6, right? So this has fewer 4s than that, and this has 1 fewer 4, right? This has 2 fewer 4s. So it might be better if we actually think about this. We've already done this, 2 plus 4n. Well, let's think about this. This is really interesting. If I took two 4s away from this, right here there are n 4s. If I took 2 of them away, well, what's taking 2 away from n? Isn't it n minus 2? Or what if I did like we said here? If I took 1 4 away, n minus 1. That might be like, what? And you don't have to completely understand this right now. So we're going to go through lots of problems and examples and things later that go with this. But the cool thing is, watch what happens when I simplify this. 10 plus, if you remember distribution, 4n minus 8. Watch what happens. This 10 and minus 8 become 2, and we have 2 plus 4n. Whoa, that's the same as we already got. And if you simplify this one here, we get 6 plus 4n minus 4. And 6 minus 4 is 2 plus 4n, and they're identical, which is really crazy. So there's a wonderful introduction to what we're going to be doing in our next investigation as we dive into our new topic.